Howdy, y'all. I'm Theo. I'm here to talk about buying time and technical decision making for your business, your projects, your teams, and all of the things that you build for your users. Who am I and why am I qualified to talk about this? Well, I worked at Twitch for about half a decade, as well as Amazon. I am the CEO of a startup, Ping.gg, focused on making great content creator tools. I was in the Y Combinator Winter 22 batch, where I got to learn all about how other companies are building, what is and isn't working, and talk to other companies from the past and see how their tech scaled. Really happy with the experience I've had working with other businesses of all sizes, hearing what has and hasn't worked for them. I'm also a YouTuber and a streamer. I do technical streams where I talk about all sorts of engineering stuff, live code, interviews to a few thousand people every week. It's still nuts that happens. Check those out on Wednesday. I'll have more details at the end. And I'm also the creator of the T3 stack, which is a stack focused on modularity and type safety for full stack application development. So, what are we talking about today? I think it's important to start with what we will be covering, which is the decision-making process for technical decisions, a light comparison of meta frameworks and how different full stack solutions and API layers can be compared and contrasted to make good technical decisions, and a general overview of modular building and how that affects cost and decision making. What we will not be talking about is performance. So how any of these solutions perform in terms of how fast is it for the user, how quick are the response times on the server, that type of stuff is really good to think about. But when I'm talking about cost and time, I'm not talking about performance. Also not talking about the history of the things that we're discussing here. There are lots of technologies that were really awesome at their times, but what we're discussing now is how we should make decisions now. So I will not be talking about the history of the stuff that we're discussing, just the things themselves and how we can make good decisions around them with what we know now. Picking tech is really important. I think we all know that. It's what we're building on top of. It affects everything from your hiring process to developer satisfaction to delivery times to the capabilities of the things that you're building. Picking tech is, as a result, an important investment to be considerate of. Just like employees, tech is a big investment that you make and are, to an extent, betting on. You have to think about the long-term impact of those decisions. And you have to bet on the people creating that tech to keep maintaining it and making sure it works the way you expect, or at the very least, you have the ability to fork it and maintain it yourself. Not a great option, but an option nonetheless. As a result of all that, picking tech is hard. Can't we just use Angular? It worked fine for Google. Tech's changing a lot, which is why I can make a joke about Angular, and we get it. It's not something that a lot of people would start a new project on right now and bet on long term anymore. It served its purpose and it helped us move forward, but it's something we've moved past. More options, and believe me, there are more options than ever right now, can intuitively lead to decisions getting harder, right? I don't necessarily think so. I think that more options have resulted in us needing better ways to measure which options make the most sense. But the idea that having more options means decisions are inherently harder to make is something I kind of want to push back on through this talk. First, though, we need a way to measure these decisions and figure out how we can compare different opportunities and options that we have as developers, business people, team leads, whatever your role is. If you're deciding on a library or a framework or a package that your company or tech, whatever, is going to consume, it's important to have a way to measure the impact of those decisions. First thing we have to measure is, of course, the cost. I like to break this into 3 separate sections: the ramp up time, the maintenance over time, as well as the ramp off time. I think that all of these are very different, and different technologies are hilariously varying in these sections. And we'll go over a couple different technologies and how they differ in this way soon. Measuring value is another important thing to consider when you're picking technical solutions. Value is measured in a lot of different ways, and the different values might mean different things to different teams and companies. Things like, how much time does this library save us? What are the wins that our users will feel from these technologies? How much happier are developers based on these technologies being picked? And how is our hiring process going to be affected as well? These are all things that we should be considerate of when we make technical decisions. I also think it's important to measure the risk of these decisions, which is separate from cost and value. What are the risks of the technology that we are picking here, and how could they potentially affect us in the future? Rather than cost, I think risk is something that we don't necessarily know, but it's something we can plan around. It's almost like the delta for how much range there is for the cost to be in, and it can also horizontally affect when you would adopt or drop a technology. Risk is the hardest of these things to measure for sure, but it is important to both measure the risk that you're taking with a given technology as well as your team, business, projects' unique tolerance for that risk. It's important to decide on these things, not necessarily eagerly and strongly ahead of time, but at the very least in a way where you can discuss them and think about them and as a result make good decisions around them. Maybe in a reflection type way, but regardless, measuring cost, value, and risk is very important as we make decisions for our technology. So this might be a weird tangent, but I want to compare two technologies that I love dearly, those being tRPC and GraphQL. tRPC is a really interesting technology that you might have heard me ranting about in other places or seen blowing up on Twitter. I think that tRPC is one of the best ways to start a new full stack application and to build APIs and communication between your backend and front end. It is a simple syntax for defining a type-safe API between your back and your front. That syntax isn't a custom syntax or its own language. It's actually just TypeScript functions being called and written. There's nothing about tRPC that you can't do in TypeScript. It is fully valid TypeScript. There is no compiler. Since it's so built around TypeScript, it is really nice to use if your backend and front end are fully TypeScript. But if they're not, you're in a bit of a rough spot. Once those assumptions are made, though, it is without question the simplest way to write backend functions and call them on the front end without losing full stack type safety. It's actually uniquely type safe. It is so fast to make sweeping changes in your projects when tRPC is the core API definition layer, because you will have inference showing you on either side whenever anything is not doing what you expect it to. It is important to consider the risk here, though, because tRPC is an open source project made mostly by one developer. That's a huge risk to take in any technology you bet on. But with tRPC, I think it's interesting as it's such a simple way to write and call functions that you could theoretically move those functions to something else without too much effort. The things that you would have to write if you were writing Express or GraphQL or another standard other than tRPC is all code you would have to write anyways. So when I port from tRPC to GraphQL, I'm not writing a lot of new code. I am copy pasting the existing code and writing my own validation and schema on top of it. So when I chose to use tRPC for a project, I chose that because I understood the risk of betting on this if it fails in the future. I understood the cost of moving off of it, and I saw the value that it provided my team immediately, and it seemed like a good option for us to explore at that point. How does this compare to GraphQL? Well, GraphQL is a pretty well-known schema language for describing and calling APIs. It is language agnostic, so you have to roll your own client and server. Thankfully, there is a wide open source community that has provided lots of good clients and servers that you can implement and use, everything from Apollo to Relay on the JavaScript side with the GraphQL Gophers project in Golang. There are lots of different options for you to build a great full stack GraphQL application, but you do need to make many more decisions around GraphQL in order to adopt it in those ways. It allows you, or GraphQL's main selling point is that it centralizes all of your APIs on a single endpoint with a single schema standard that everybody agrees upon, and then you don't have to talk anymore. GraphQL is almost a communication method between teams as much as it is a standard or a method to call an API. I think that one of the biggest reasons you would pick GraphQL is to de-risk. The GraphQL standard, the schema language that we use to define GraphQL APIs, was created by Meta, the Facebook, and they built it as a very strong, focused standard. And now there is a gigantic community of people building packages around it, both for the backend and front end in various different languages. So your Swift mobile app, your Kotlin Android app, your Xbox app, your weird Windows thing, your Python backend, your Golang nerds at your company, everybody has an option to work with GraphQL right now. For that reason, it's a huge difference between GraphQL and tRPC in the point at which you would have to offboard as well as the cost of that offboarding. So how do we measure this? I have a bit of a weird visualization that I think does a pretty good job of communicating how I like to think about these decisions. On the vertical axis here, we have cost. Cost is left vague kind of intentionally. It's meant to represent the cost to yourself and your business. It is a combination of like time, financial investment, and a little hint of risk, but it was kind of hard to fit risk into this chart, to be fair. So think of cost as how much impact and I guess drain does this have on the people building this thing, and like how much time are we gonna have to spend building and maintaining this thing? And as a result of that, how much less time can I spend building the functionality that our software is made to or built for and serves our users directly? We break those down into 3 chunks, which are ramp up time, maintenance cost, and offboarding cost. We'll discuss those a bit more in a bit because I want to talk about the x-axis, which was so hard to decide on. I kept picking additional arbitrary things, but the one that felt the best was employee count, because the number of employees in a business represents a lot of different things. It kind of represents the success of a business because a successful business can hire more people, but there are plenty of successful businesses that don't, so it doesn't necessarily correlate with that. That said, a business with a small team that is very successful probably has a simpler code base and system to work in by choice, so they might choose different technologies based on that. There are also companies that have chosen, or that know in order for them to succeed, they need to have 2,000 employees in a few years. And because of that, the technologies they choose might be entirely different because they are thinking ahead to where they want to be for the things that they're building. Employee cost is something that, or number of employees isn't something that is a perfect one-to-one way to measure what technologies make the most sense, but it's a good way for business like leaders and people running projects to think about how is this project going to change over time. So if you have one project that is a side project you and your friend are working on and you don't ever plan to have 100 people working on it, versus a project at work that's a greenfield thing that might get kicked to a team with 50 people in a few weeks and then might grow to a much bigger team with hundreds working on it in the future, the technologies you pick for those situations should be very different. And I think it's a good way to measure how we can decide between them. So with tRPC, we should first obviously talk about the ramp-up cost. As much as I love tRPC, you do need to understand it pretty well to get started with it effectively. And because of that, it is not the smoothest thing to get started, and the onboard cost is a little high. Once you have all the boilerplate set up, though, it is very easy to work with, and usually it's a thing one person has to do, and then the rest of the team can just cruise on top. This has very much been the experience that we have had, as you can see with the flat line here. Maintenance cost has been effectively flat as we've grown the team and continued working with tRPC. You just write functions and call them. Once it's all set up, you're good to go. However, tRPC does have problems where if you have enough functions and enough endpoints defined in it, the TypeScript compiler starts to slow and down to an absolute crawl, eventually crashing and throwing annoying errors when you're developing just because of the amount of TypeScript inference going on within tRPC. So there are actually code base sizes where tRPC isn't a valid option right now. And because of that, you do have to plan for if a code base gets big enough to move off of it. That planning is something you should do relatively early, depending on if you're choosing tRPC. But like for me at Ping, I want to write these functions as fast as possible and get functionality out to my users. We have 5 people working on Ping right now. It is not that big a deal for us to make it way smoother to get those things out, knowing that we can pay this cost in the future when there's a technology that makes more sense for us as the team and the code base grows. So how does this compare to other things? Well, I'm going to self-plug for a little bit because I want to point out an interesting detail about these costs. There are ways to reduce them outside of the technologies themselves. With tRPC, that boilerplate cost is massive. But as I mentioned before, there are other, like once that's set up, you don't really need to touch it anymore. And the vast majority of the engineers working on the tRPC projects I've worked on don't know anything about or care to know about that boilerplate. They're just writing and calling functions. Because of that, I worked with some of my community. I should be honest, they did all the work here. I just came up with the idea to build a project called Create T3 app that has the explicit goal of knocking down the onboarding cost to be as cheap as possible so that you can get spun up quicker. The whole project's bootstrapped and boilerplated for you with all of the weird interactions between things like Nextauth for authorization, your database through something like Prisma, all of the modular pieces that I would assemble around tRPC and the knowledge necessary to do that has been paid off in advance by the Create T3 app maintainers. And as a result, the onboarding cost is a lot cheaper. We also see here that the maintenance cost is the same because the technology is the same. It's just a faster way to get started. And the offboarding cost is, I would argue, a tiny bit more expensive because that's the point where you need to better understand tRPC and kind of pay off the debt that you chose at the beginning by using a project like Create T3 App. But I honestly don't think any of that's going to matter until you're deep into moving off or migrating some heavy things on top of tRPC. So how does this compare to GraphQL? Well, GraphQL is a bit of a beast. The onboarding cost is significantly higher because you're not choosing one technology, you're choosing like 5. And those decisions are all things you have to research, make, do, and understand. There are prescriptive solutions like Apollo, but honestly, those solutions tend to fail faster. I could put like 15 different lines on this chart for the different ways you can do GraphQL. This is meant to be kind of like a vague generalization. All that said, if you do GraphQL right, every time you add or remove something to and from your schema, there is a cost to pay there. Your schema's like nature of it being consumed by so many different places, many of which might not even be in the same code base, means you never have a proper guarantee when you're making a change to the GraphQL schema that the clients will expect and respect that change. That's an inherent maintenance cost to using GraphQL. I watched us paying this off regularly when we moved to GraphQL at Twitch. It was absolutely worth it though, because the alternative was comms challenges and cost between the backend teams and the front end teams working on different things. The benefit of GraphQL here was not necessarily as a technology that magically solves all our problems. Rather, GraphQL was a method for us to communicate better and define standards between the backend and front end teams such that we could build and scale our applications more effectively. That said, if we ever had to move off of GraphQL, we're screwed. I intentionally have that line going off the chart here because it is unimaginable once you've deeply bought into the GraphQL ecosystem that you could reasonably ever move off of it. But as with Create T3 App, there are ways to pay off some of those earlier costs. I mentioned Apollo before, which is a good option, but I really want to talk about another that I've been hearing more and more is the competition for Create T3 App, which is Redwood.js. Redwood.js is a full stack TypeScripty, like Next.js-like web development solution for full stack applications. The big difference between it and something like Next.js is that Redwood has a very strong GraphQL layer between. So when you want to get data from your backend to your front end, you write a GraphQL schema for it. You make those changes in the backend, and just by really writing a TypeScript function. And now you can call those things in the Redwood.js client with ease. The reason that I think that Redwood.js can scale to larger team sizes than something like tRPC or Create T3 App is because of its use of GraphQL. It means that if you hire somebody who does not want to use TypeScript, or you have a very specific client or need where you have to be writing this thing in Swift or Kotlin for the mobile apps, the GraphQL standard that Redwood is built on allows you to consume the same APIs on those other clients. That all said, Redwood is built with the expectation that the majority of the consumption and the majority of the definition of your GraphQL exist inside of that Redwood project. So as it gets big enough and slow, the benefit of GraphQL, which is the decentralization of the backend with a centralized schema, means you have to pay a lot of cost to move off of Redwood. So yeah, it is important to know these things when you make these decisions, because while Redwood can get you a good bit further than the T3 stack can in terms of how far your business grows, when you do hit that cap, it is going to be very expensive to move off it. And as you see here, the end cost of any one of these technologies is very different. Betting on Create T3 App over the lifespan that you could use it for a growing company will cost that company less time, energy, and like effort and sanity from the engineers than even tRPC would. And Redwood.js will be at a similar point when Create T3 App dies. You see that that's right around like the same cost where Redwood would be at that point. However, once you get to the 400 or so employee point, again, arbitrary, the cost of moving off of Redwood is significantly higher. In fact, once you've paid the cost of moving off of Create T3 App, that's the point where you get to where Redwood is right then. Again, this is all very arbitrary, and it's going to depend a lot on the business that you're building or projects that you're like working on. But this is lined up with the experience I've had consulting with companies and talking to developers who have used all these different technologies. That all said, this is one of the biggest benefits of building modularly. With Create T3 App and tRPC being relatively modular solutions, the cost to move off them is pretty cheap, and you can move to anything else at that point. So what are some things that we should be considering when we do these measurements? The one thing I didn't touch on quite enough in that diagram is risk. I think the best way to measure risk, which was hard for me to visualize, would be the extension or potential shrinkage of the horizontal distance something could go. tRPC, for example, if your project has tons and tons of endpoints, even with a small team, you might have to move off it sooner, which could cause that horizontal distance you get to be way shorter. With something like GraphQL or even Redwood, you might need to start hiring a bunch of people who aren't engineers, and the code base might make more sense as a monolith. Maybe you have one or two contractors working on iOS and Android, and you just need a way for them to get that data, and you really can't use React Native because they prefer that thing. That is almost an inverse risk where Redwood lets you go way further than you might have otherwise. But risk is kind of a horizontal extension or shrinkage in the context of that chart. And every business has its own risk tolerance, and you should be considerate of that as you make decisions about your technologies. Client needs are also incredibly important to consider. I think that clients are, to be frank, the often forgotten part of these discussions. We'll occasionally say things like, yeah, users will stay on our websites longer and get there and engage with them better if the TTLs are significantly faster. There's that famous Amazon thing where it's like a couple hundred milliseconds caused like a 10% shrinkage in their number of checkouts. I think that we talk about it when we can talk about like raw numbers that are exciting to us as engineers. But when it comes to what the users need and how we can deliver it for them, I don't think we talk about client needs in those ways. And it's important to think about what your users need and what they might need in the future when you make technical decisions. It's also important to think about the current team you have. Who's on this team? What technologies do they use? What are they familiar with? And how is this technology going to affect their current standing at their job? Not necessarily in like are they going to get fired way, but in a how are they going to feel themselves about the work that they're doing? Technology choices have a huge impact in any given developer's day-to-day experience at a company. And as such, even as like a really opinionated business leader who's built a lot of technologies, given the opportunity for one of my engineers to adopt something they're confident is the right solution and I'm less sure of, even if that's something that might burn and fail, that makes them happier and keeps the team content, it might be worth taking that risk, knowing that developer satisfaction is essential to retaining your team and building great things. On top of all of this, you need to be considerate of the future. The future is hard to predict, but it is important to think about it and what your goals are. Different projects have different expectations. Where I have a lot of projects I'll be the only developer on. I have a lot of projects where if things go well, all of the code I wrote will be deleted and replaced with code by the 10,000th engineer working on it. As such, the things you pick, how modular you should go, and all these types of decisions should be considerate of where you expect this project to be in the future. That was quite a rant. I really was excited to talk at Composability Summit. As y'all know, I'm really into modular solutions. And as I plug here, Create T3 app is the best way to start a full stack project with a modular set of tools you can pick from as you init. You actually get asked questions. Do you want tRPC? Do you want Prisma? Do you want Tailwind? Do you want Next-Auth included? And that lets you construct the application or the boilerplate you need to start with for your project. And at any point, you can add and remove those pieces or swap them with other things that make more sense. The goal of Create T3 app was to make it easier to onboard onto these new solutions without having to give up the offboarding cost wins of the modularity in these pieces. Since we have made it easier to get started with these technologies, you still get the win of how easy it is to get off them and the benefit of using them throughout without having to pay the upfront cost of getting started with them. If you want more rants like this one or just more in-depth deep dives on all the things we talked about today, make sure you check out my Twitch, twitch.tv/Theo, as well as my Twitter. T3.gg is the Twitter handle there. You can find links to my YouTube on both, which is probably the best place to catch my content. All of the things I do on stream that are worth watching, I tend to upload on YouTube a few weeks later, so keep an eye out for that. Thank you again for having me here for the first ever Composability Summit. This is a really cool idea for a conference. I love me some good modular solutions, and composability is one of the most important things to consider when picking your technologies and thinking about the cost and value you get from those decisions. It's also, without question, the easiest way to reduce the risk of any technology bet that you make. With all that said, thank you again for the time. I really appreciate it. Peace, y'all.
Hey, thank you so much for watching that. I really hope you got value from it. By the way, if you want more where that came from, go to composability.dev and register to be a part of our community today. And if you want to be even more part of our community, go to Twitter and look up JavaScript Jam and follow us. Every Wednesday, we go live at 12 p.m. Pacific Standard Time, and we talk about anything and everything web dev. It's an open mic for everybody, whether you're a beginner, whether you've been doing this forever. We love to hear from everybody, and there's always so much value and good conversation going on there. We wanted you to be a part of it too. So come join us. And by the way, if you left a comment below, that's exactly where the comments are going to be answered during the live Q&As with the speakers. JavaScript Jam live on Twitter Spaces. All right, go to JavaScript Jam. Do it. Do it now.